Doing a quick video here on a frequency counter. It is manufactured by Systron Donner, I think is how you pronounce this. Not sure if I have the pronunciation right on it, but anyhow, is the model 6252. Cannot find any schematics. I have found a 6250 out there floating around on the web that I have kind of modified here to match kind of the unit that is here. It got me anyhow in the right direction. Normally it's not too easily to do this, but sometimes you have no other choice if you're trying to repair a counter. This counter had still yet had display problems. It had the neon displays, kind of similar to the Nixies, but they're not Nixies. Manufactured my own little board, and the same pinouts on this connector here is a kind of a 25 pin connector here on my board that I made here, and the pins match the main motherboard pinout. So pin 1 is pin 1 of the connector, and so on. Anyone's familiar with this counter, noticing, well, that doesn't look like the normal displays, and it isn't. These are TIL311 displays with logic. There's a supply of them floating around kind of on the internet that was fairly cheap, so I picked me up 8 of the TIL311s and created my own little drawing here. This is my circuit that I made here for the TIL311s, and had to kind of make up here. These connections right here are, say, the same number pin that's on the actual motherboard itself. So pin 1 on the motherboard is pin 1 on this connector, and so on. They kind of follow this. Here's a list of the ICs that I used, and you may be able to kind of follow this logic, kind of design your own, or use some of the ideas that I've went along here with. You could probably choose another LED display or any kind of display and kind of work it out on this system. The 5 LEDs are still still the same LEDs that are on there. Were just removed from the original glass displays and moved right over to this one. Note on the blanking, we did have to invert the blanking line going to the new displays. Also, in your design, the unused inputs of the LSO4 need to be tied low or logic high. Either one, you just don't want to leave them floating, and I didn't draw that on the schematic, but they are in fact not left floating. And we're using the right hand decimal points and using the 74LS138 as the decimal point decoder. When I got this counter, like I say, the display was totally out. The neon displays have done expired and evidently were leaky or gassy and no longer would light up. Also, as well, this suffered from some logic issues. The timing that controls the display, which was the IC that's responsible for it, is actually these 3 right here, and this one here, the 7281 right here was actually defective. causing me some timing issues, and some of the displays were lit up and some were not, so I had that to deal with all at the same time of designing this front panel board here. Also, I had one of the counter ICs, which is the all of these are the 52 series. There is one that is at the first, it's on the first display, that is a 51, and it is a little bit different flavor, and luckily it was good. I did swap around, so if you note that this 0 right here over in this corner is the faulty IC, so I moved it over all the way in the last position, and I'm going to build a custom IC because these ICs are very expensive and is no longer really feasible. So I could actually build this because I actually pulled the data sheet of that particular IC, so I will be able to make a custom board that will say replace that IC. Like I say, the display and the common logics is probably the only issues that you will have probably out of these counters, other than the counters themselves. And like I say, once I get a custom IC built for the position 8, I think originally I had maybe position the 3rd or 4th digit just kept displaying a 0 all the time, or either an 8, just every which random state it pops up in. And I swapped that. I actually originally thought that I had some logic issues that I could deal with, and probably some input signaling that was causing some issues. Kind of down in here, I figured, well, I had some issues here, but all this checked out okay, and it turned out to be a flaky IC, which was causing me problems. So I just removed one out of the furthest position, moved the good one from here, and swapped it, put a socket in and swapped it over, and brought it over here to this position. And really, I could probably I can use the counter as is, because this display over here is probably going to rarely get used, so it's not that important. So anyhow, if you've got one of these counters and trying to look for a manual, I've noticed that doing some search on the web that a lot of people has requested a manual, couldn't find a manual in the States here. And if you can't find the manual, you can find the one on the web, the 6250, and it will get you close. You'll just have to kind of label your IC positions, are all different. And of course, if your display is bad, you can build a custom display. And I built this display here, and took quite a little bit of time because I was just on and off on this project, but it wasn't too stressful. It wasn't bad at all, and everything went kind of straightforward. Even though I had a bad counter IC and a timing IC, it really threw me off a lot, but eventually we kind of realized that, hey, our logics are correct, and we just got some failed ICs, and we got down to the problem there and replaced the timing IC, and that was the 7281 that was giving some particular problems. We'll note on my unit, the 7281P series is a Motorola IC here. It is marked U4 on this schematic here, which is not U4 in the actual unit that we have here, but it is wired differently. I did not expect that, because U3 is wired the same and U5 is wired the same, but U4 has had some modifications from the factory, and you will have to kind of follow their little pattern that they have done there, but nothing that you can't just figure out from the actual 6250 schematic. So if anyone happens to have a 6252 schematic out there, or know of one on the web, hopefully you can attach a link or something to this video. It would be kind of helpful to actually have the correct manual. But so far it is now back in operation, and everything seems to be okay. We're not using the high voltage anymore, so the pin 24 is just not connected. Again, I'm going to go back and either put a small neon lamp on that load so that voltage will not be floating, or I will either remove the rectifiers and kind of just disable the high voltage source that ran the neon gas displays, just to kind of keep it from floating, because I just don't like the fact that it's sitting there with no load on it. It probably ought to be loaded with, say, just a neon lamp or something. Would be sufficient just to kind of keep it loaded. Anyhow, hope this might help someone who may have the Systron Donner 6252 that can't find any manual out there. That there is a little bit of hope that you'll be able to take the 6250 manual and kind of troubleshoot enough to get you running, and you may have to end up building a custom display for the expired neon displays. Like I say, they're getting quite old and they're at their end of their life, and the LEDs will be a much longer lifespan in this application. So hope that helps someone.